Hello and welcome to Military and Aerospace Electronics Tech Summit, quick chat with rugged computer specialists, Sealevel Systems Incorporated in Liberty, South Carolina. I'm John Keller, Chief Editor of Military and Aerospace Electronics. Today's presenter is Jeff Baldwin, Director of Engineering at Sealevel Systems. Thanks for joining me today, Jeff. I understand you're here to tell us something about the challenges of ruggedizing computers to perform in aerospace and defense environments. So I've got some questions here, and the beginning is, when beginning the rugged computing design process, what environmental factors do you and your customer need to know about to create a product that can operate reliably?
Yeah, sure. Detailed understanding of the environment is crucial. You need to know the temperature extremes that it's going to experience, obviously. But then, if there are certain durations that it dwells at certain temperatures, if it's a very short time frame, it might affect the design a little bit. But then also just what other devices are around it. If there are other heat-producing pieces of equipment near what we're designing, that we need to take that into effect. Airflow is crucial. Airflow is critical for getting heat off of components. So if it's present in a certain level or not present at all, then that needs to be taken into account so we can scale the system properly.
Okay. What about the actual operating environment itself, where it's going to be, say it's going to be in the desert or in the Arctic, if it's going to be out on a runway tarmac or a shaded area? What are some of the considerations that you and your customer need to chat about, as you're moving forward?
Yeah, certainly those environments all have their own unique challenges. Desert can get very hot and very cold at night, so the full range is required there. Inside applications are a little simpler usually, but then if you are outside, then you have solar loading, which is just additional radiated heat onto the device. It all needs to be accounted for and dealt with properly through thermal conduction and low power designs.
Okay. Talk to me a little about the thermal solutions that you found to be most successful, from component selection to placement to simulation.
Mm-hmm. Yeah, so component selection is crucial. One of the most important things at the beginning, you have to pick devices that can operate in the environment you need. But then also understanding the full environment and the size constraints and also functional constraints of the system. Understanding how the devices themselves are going to operate. If parts are going to get hotter than others, power supplies can be heat producing elements based on the efficiency, and other devices are just consume power and dissipated in the form of heat. And so understanding how much is going to be coming out of each component, and then strategically place them in the design within reason, because you do have real world limitations, like a port has to be here, the device, one bus has to come out on this side to interface with other equipment. So within the constraints of the specifications, spreading heat out. And then after that, it's the heat that you do have to deal with, remove it from the system. Typically, we like to do designs with fanless solutions, because a fan is an extra piece of cost and complexity and moving part, which can be a failure method. So if we can eliminate moving components, that usually gives us a more reliable overall design. So then at that point, you have to strategically sink the heat away from the devices and escape them from the system completely, so they don't well up and drive other components out of their operating ranges.
So how big a deal are some of the existing and emerging open systems embedded computing standards that deal with thermal management, like some of the Vita standards, and also some of the new SOSA standards? How big a role do you think those standards are going to play moving forward?
They can help or they can hurt that. So if there's provisions in the systems that provide the allowance of thermal solutions, and that's very beneficial. Specialized connectors that can provide some thermal heat sinking themselves, and other solutions like that.
Okay. Engineers sometimes underestimate the challenges of a still air environment. What's your experience with still or stale air and its influence on system performance?
Yep, it is certainly a challenge. And certain components, when they're specified for their thermal environments and their thermal capabilities. They're kind of, those specifications are provided a little bit in a vacuum. And so you really have to take the whole system view. Thermal simulation can be very helpful. You can simulate all the internals and how the heat's going to flow through the system and escape. So that can be helpful, but then it's no substitution for testing. You have to understand the full environment, and then once you're in the environment, you have to test it thoroughly. You know, lots of monitoring inside the enclosure and on the components, and verify that they all stay within their design ranges.
Right. Well, when you're talking about air cooling of any kind, what's your thinking about when a customer tells you that the computer has to operate in a contaminated environment, be that salt spray, dust, sand, potentially fungus, things like that. What are some of the things that you can do when it comes to thermal management to prevent the contamination inside the computer, and also remove the kind of heat that you need to get rid of?
Yeah, that certainly adds an extra constraint to the system. If those environmental contaminations are going to be present, then you need to either seal the system up from the enclosure standpoint, and so you've got less ability to move air into and out of the system to cool them. So after that, you might need to resort to other methods like conformal coating and other internal protections to protect the electronics.
So when it comes to conformal coating or any of those areas that would be essential in protecting against contamination, how does the conformal coating itself influence your thermal management constraints? And also, how does that affect ultimately the cost of the system? Is it expensive to do that? And is it worth it? What are some of the cost trade-offs that you're going to talk to your customers about?
Yeah, oh, it can be certainly worth it if the environment requires it and your application can't fail, then it just is required. But it certainly adds cost, not only as a material, but also in the manufacturing process. It's extra steps, extra labor, extra machinery. But you also have to take measures in the design process to account for it too. If when you want to coat all of the electronics, you can't have certain connectors and certain components too close to each other, because your process has to be able to get the conformal coating everywhere it needs to be to protect the electronics.
Right. Now, do you ever deal with extreme cases that might lend themselves to any kind of liquid cooling, or are you primarily recommending the conduction and convection type forced air cooling?
Yeah, we recommend the conduction cooling, just with metal solutions. We do use some heat pipes these days that move a fluid through the design to remove heat more efficiently, but not true liquid cooling with with pumps and stuff. We don't usually use those in designs.
Right. Okay. Another area that can be overlooked is designing for tolerance to power disturbances. Tell me about potential solutions that you use to mitigate the effects of electrical outages, brownouts, spikes, and other voltage variances.
Yep, power disturbances are a huge consideration in system design. They can damage equipment or just cause it to momentarily go out of service, which can be a big problem. If it's just a matter of protecting the equipment, there are plenty of passive and also active devices, surge stoppers and TVS diodes and things that can be used just depending on the environment. It's always just crucial to understand the environment and what the system may come across in its normal operation. Then, brownouts, sometimes ultra caps and other capacitive and battery storage solutions can ride out short disturbances. And then if you have to go with the full power outage, then you need a longer solution, battery or generator backed solution.
Well, does dealing with power variances, can that complicate the thermal management challenge, or is that really a separate issue?
It's usually doesn't hurt it too much. Those devices they usually don't dissipate too much heat ongoing. So no, it's usually not a difficulty there.
Okay. Well, thank you again, Jeff, for your time today. Just a reminder that today's session will be available here within the Military and Aerospace Electronics Tech Summit platform for the next 30 days. So on behalf of the Military and Aerospace Electronics Tech Summit and our sponsor, Sealevel Systems, we'd like to thank you for joining us today.